Okay, this is a brief video to dive a little deeper into layer 3, which is the network layer of the OSI model. So here's some information that we need to know about layer 3. Again, it is the network layer. The PDU, which hopefully you already know, is the packet. And the purpose of layer 3 is to transfer packets between the source and destination devices, and which will be IP packets, and then to encode and decode those IP packets. Again, components at layer 3 are routers, and as far as the addressing at this layer, we have either IP version 4 packets or IP version 6 packets. An IP version 4 address is 32 bits. An IP version 6 address is 128 bits. If we look at the IP format, this is what we have. We'll go back and look at some of these a little closer. We have the version, which is what version of IP do we have, so they'll either be 4 or 6. The internet header length is going to be the number of 32-bit or 4-byte words that are in the packet. TOS is type of server. We'll talk about that in more detail. We have an identification field that is primarily used for identifying a group of fragments. We have flags, which talk about is fragmentation allowed or not. If fragmentation is allowed, and this is a fragment, what is the offset in the data that we are sending? We have time to live, which is so packets don't get in an infinite loop and continue cycling through the network between routers. Basically what happens is this is set to one value, often either 128 or 255. Each time this packet goes through a router, that value is decremented by 1, and if it ever hits 0, the packet is thrown away. What protocol packet do we have? For example, hex 6 implies it's a TCP packet. Hex 11 implies that it is a UDP packet, and hex 1 represents that it's an ICMP packet. Those are the three that we will care about the most, or possibly at all in this class. We have a checksum to check the header to make sure it's intact. And then we have source and destination addresses. Again, this is an IP packet, so these will be IP addresses. And what I've shown here is for, excuse me, IP version 4. We may have options. If the header length is 6, this may be an options field, and then we have up to 65,536 bytes for the actual payload or the actual data. So we, in the previous videos, looked at the headers for layer 2 when we're talking about layer 2. Now we're talking about layer 3. So let's go back to the same packet we were looking at before, and this time we're going to click on IP version 4. So it is highlighting in the right half of this the bytes that correspond to the IP version 4 packet that we're looking at. The total length is 3F, which is 63 in decimal. Notice that we have the value decoded. You see total length :63 in the left hand side of the window. The next thing we have is the identification field, which is used to uniquely identify the packet. Next we have fragment offsets. Both the flags are 0 and the offset is 0, which means we did not fragment, or this is not a fragment of a packet. The next thing we have is the time to live. I told you that common values were 128 and 255. So this one is 128. And then we have the protocol, which is 11 hexadecimal, which is 17 in decimal, which implies this is a UDP packet. So if we continue looking at this, we have the header checksum right there. And then the next thing we have is the source address, which is shown in hexadecimal there. I converted that to decimal dotted notation, which is 128.163.9.21. Notice up in the very top line that's highlighted in blue, it shows that as being the source. The next thing we have is the destination, which is also shown in blue at the DST. The rest of the packet is the actual UDP message, which is layer 4. So when we come back in layer 4, the next video, we will continue going through this Wireshark capture.